All right, so here we go. Finally, we are on the road with 11.4, and we're going to be talking about inequalities again, but we're going to be talking about inequalities that are not linear inequalities like we were working with before. Specifically, we're going to be talking about two different types of inequalities. We're going to be talking about a quadratic inequality, which can be any one of these forms. So it can be greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. And we're also going to be talking about, on the second page, we're going to be talking about rational inequalities. So we'll have fractions. Okay, since we know the graph of a quadratic equation is a parabola, we can envision what the solution might look like. So if we were to go ahead and if we were to graph this parabola. Now, we're going to spend a lot of time graphing parabolas in a couple of sections, but just if we were to go ahead, so let's see, just really quickly to help me graph, if I were to factor that, it would factor into x minus 5, x plus 2. So I would get x equals 5 and x equals negative 2. So what that means is that it's going to cross the x-axis at 5 and at negative 2. We know it's going to turn up. So again, I'm not going to plug in any more points. I'm going to just kind of estimate. And again, this is an estimate that this graph kind of sort of looks like that. Well, if I wanted to graph all the points less than that, do you see where I would be talking about all of that section right there? So graphically, that's what we are going to be looking at. And of course, if it was greater than, it would be up inside the parabola. Okay, but we're not going to do it graphically because we haven't spent a lot of time graphing these parabolas. That was just a visual for you. We're going to solve it using algebra. So here are the steps to go ahead and solve it using algebra. So the first thing that we're going to do is we're going to solve the related equation. Then we're going to look at a number line and we're going to separate that number line into regions with the solutions from the equation that we solved. From each of those regions, we're going to take a test point and we're going to test it. And for those regions where the test point is true, that's going to give us our solution set. So we're going to be able to go ahead and solve. Okay, so let's go through those steps with this first one. So the first thing we're going to do is we're going to pretend as if it were an equation. I'll even rewrite it, and I'm going to solve it. Well, how do I solve this? Well, I'm going to factor. It's a quadratic. I can take an x out. And if I take each of these factors and set it equal to 0, I'm going to get x equals 0 and x equals 6. Now, what am I going to do with that? I'm going to draw a number line over here. And I'm going to use those two values, and I'm going to put little dashed lines. So what I did is I used those two values, and I separated my number line into 3 regions. One or more of those regions will be the solution to this inequality. So now what do? Is I take a point from each one of those regions and I test it into my inequality. If it's true, it's a part of my solution. If it's false, it's not a part of my solution. So let's start at the left here and let's just take negative 1. Well, if I plug negative 1 into this inequality, it would be negative 1 squared minus 6 times negative 1 is maybe less than or equal to 0. Well, let's see. That's going to be 1 plus 6 is less than or equal to 0. How's that looking? I don't think that's going to be true. So since that's false, I'm going to go up here and I'm going to put a little x there just so I don't forget. Let's take something from the middle region and test that. Again, it can be anything in there. How about if we test a 3? Well, if I plug a 3 into my inequality, I'm going to get 3 squared minus 6 times 3. Is that less than or equal to 0? Well, I'm going to get 9 minus 18. Is that less than or equal to 0? That's looking pretty good. So I'm going to go up here and I'm going to put a check. And finally, I'm going to take something from this region over here. I'm just going to take a 7, but again, I could take a 500 if I wanted. If I put a 7 into that inequality, it would be 7 squared minus 6 times 7 less than or equal to 0. 7 squared is 49 minus 42. Is that less than or equal to 0? No, it is not. So this region is going to be an X. So my solution set is this region right in there. Now, we're going to write it in interval notation. Because this is less than or equal to, our solution would be all solutions from 0 to 6. Oops, but we would put brackets because it's 0 to 6 inclusive. And there we've solved that polynomial inequality. All right, let's go ahead and let's solve this one. Now, you can see that this is already factored for us for that, so that's nice. But you can also see that it's going to cause us a problem because when we go to divide our number line, we're going to have a little line on 2, a little line on -1, and I'm getting these values by taking these and setting them equal to 0, and on -5. So I'm going to have 4 different regions that I have got to check a test point. So let's start down here and let's try -6. So if I plug in -6 into here, well, let's see, -6 minus 2, I'd get -8 times -6 plus 1 is -5 times -6 plus 5 is -1. Is that less than or equal to 0? Well, I can tell because there's 3 negatives, my answer is going to be negative, which is definitely less than or equal to 0. So that's a go. Let's go ahead and let's plug in something from this region. How about -2? So if I go ahead and if I plug in -2 for x, I'm going to get -4 times -1 times 3 is less than or equal to 0. Well, multiplying those, I get 12 is less than or equal to 0, which is not true. So that's an X. We'll just keep going to the right. Let's go ahead and let's use 0. So if I plug 0 into each one of those parentheses, I'm going to get -2 times 1 times 5. Is that less than or equal to 0? Absolutely, because that's -10. And finally, why don't we go ahead and let's plug in something from this region. Let's go with a 3. So if I plug a 3 into each set of parentheses, I'm going to get a 1 times a 4 times a 8. Is that less than or equal to 0? No, it's not. So that's going to be an X. So these two regions are going to be my solution set. So that would be everything from negative infinity to -5 bracket, because of the equal to sign, union with this region right here, which would be everything from -1 to 2. And there we go. So when we do now solving rational inequalities, this is what it looks like. The same steps apply, but there's a twist. And I'll tell you about the twist when we get there. So the first thing that we're going to do is we're going to solve the related equation, just like we did for the first two examples. So now these are going to be easy because if I put a 1 under here, do you see where I could cross multiply? If I cross multiply that way, I get -3 is x minus 3 is equal to, if I go this way, I'm going to get 0. So x is equal to 3. So there's one solution to this rational equation, and that's at 3. Here's the twist. When you have a rational inequality, you also have to put a divider line on any value that would make the denominator equal to 0. You have to put a divider line on any excluded value, which in this case would be -5, because if I were to take -5 and plug it in there, I would get a 0. You don't want an undefined fraction. So not only do you have to solve the equation and get your answer to put one number line, you also then at the same time have to do the denominator not equal to 0. So now we just do the same thing. So let's plug in a -6 from this region. So -6 minus 3 is -9 over -6 plus 5 is -1. Is that greater than or equal to 0? It is not, because this is 9. Let's choose 0, because that's from this region. 0 minus 3 is -3 over 0 plus 5 is 5. Is that less than or equal to 0? Absolutely it is. And let's go to this region and let's choose a 4 and just check that. So we'd end up with a 1 on the top and a 9 on the bottom. Is that less than or equal to 0? No, it is not. So this middle region is our solution set. So it would be all numbers. Now we have to be careful. We can't include the -5. It doesn't matter that this is equal to. We can't include the -5 because that would give me an undefined fraction. So it's parentheses, -5 to 3 brackets. All right, we have one more to go ahead and do. So let's go ahead and let's solve this as if it were an equation. Still going to cross multiply. So if I go this way, I'm going to get 3 is equal to 2x minus 4. 7 is equal to 2x. X is equal to 7/2. So in our number line, we're going to go to 3.5. Because that's what 7/2 is. And then we're also going to put a line on 2, because that is what would make it a 0 in the denominator. So let's go ahead and let's pick some values and plug them in and see if they work. So let's start at the left. Let's plug in a 0. So that would be 3 over -2. Is that less than 2? Well, this is -1.5. Absolutely, it's less than 2. How about if we plug in 3? That's the number, that's a good number in between there. So if I plug in 3, I'm going to get 3 over 3 minus 2. Is that less than 2? Well, that's 3 over 1. That's not less than 2. Oops. So that's an x. Let's plug in something greater than 3.5. How about a 4? If I plug a 4 in, I'm going to get 3 over 2. Is that less than 2? Well, that's 1.5. So absolutely, that's less than 2. So now notice this is not an equal to. So our values would be everything from -infinity to 2 parentheses. We don't want to include the 2. Union with, we also don't want to include the 3.5 because there's no equal to there. So 3.5 into positive infinity. I'm going to quick check and make sure we're good. Absolutely. There's the end of 11.4.